Let's go ahead and look at the quotient rule next. And the quotient rule, you'll recall, that's when we're taking the derivative of one function divided by another function. So f of x, that's an x, f of x divided by g of x. And again, the temptation, just like with the product rule, the temptation here would be to do f prime of x divided by g prime of x. Unfortunately, that's not going to get you the right answer. So let's recall the quotient rule says that this would be g of x times f prime of x. Let me just clear that up just a little bit. Sorry. F prime of x minus f of x times g prime of x, all divided by g of x squared. Okay, and I'll remind you that we said that even though it sounds funny, it helps to remember low d high minus high d low all over low low. Okay, so that's the low, the g of x times the derivative of f of x minus the high is f of x times g prime of x divided by g of x squared. Low d high minus high d low over low low. Sounds ridiculous. It really helps. Okay, so let's look at a couple of examples. So first of all, we'll just start with a straightforward rational function. We have a polynomial in the numerator, polynomial in the denominator. And so we just start out, we say low is x squared plus 1. And d high, derivative of 5x minus 2, is just 5. Minus high, it's 5x minus 2. D low, the derivative of x squared is 2x, and the derivative of 1 is 0, so we don't have to include that. And then we put that all over x squared plus 1 squared. And now we will usually just leave this like it is. We won't simplify that down. Although if this were a multiple choice test and you didn't see anything that looked like x squared plus 1 squared, but you saw things with x to the fourth in them, then you could go ahead and do FOIL to square that denominator. But most of the time they just go ahead and leave it in that form that we have it here, x squared plus 1 squared. But we do want to simplify the numerator as much as we can, so we will say that's going to equal, distribute that 5, we get 5x squared and plus 5. Now let's be careful here. We've got to distribute the minus, so we get minus 5x times 2x, which is going to be minus 10x squared. And then we get minus 2, so 2 negatives make the positive 2, times 2x is plus 4x. And finally, that's all over x squared plus 1 squared. And we can combine any like terms on the top. 5x squared minus 10x squared is going to give me negative 5x squared. I've only got the plus 4x, that's the only x term, and I've only got plus 5 for the constant term, and then I keep the denominator just like it is, and that's the derivative using the quotient rule. Alright. Now let's look at another one that's pretty similar, except we do want to simplify this just a little bit before we start actually taking the derivative. So notice here that we have what we call a compound fraction. We have a fraction in the numerator of a fraction, and we really don't want to deal with that. So what we can do here is we can multiply by the denominator of this smaller fraction. So see here, this smaller fraction is 1 over x. I'm going to multiply by x over x. Now notice, this is our old trick of just multiplying by 1. And so it's not really changing what's going on here, it's just changing how it looks. So when we distribute that x on top, we get 3x, and then 1 over x times x is just 1. And then in the numerator, in the denominator, we distribute the x down here, and we get x squared plus 5x. And so let's work with this form of the function rather than that first form, because it's just a little simpler to deal with. So once again, we just go ahead and we say low, x squared plus 5x. D high is just 3, derivative of 3x is 3, and derivative of minus 1 is 0, minus high, 3x minus 1. D low, we get 2x plus 5 for the derivative of x squared plus 5x. And then we put all of this over x squared plus 5x squared. And then we just continue just like before. We want to, we're going to leave that denominator just like it is, but we're going to simplify where we can on the numerator. So I'm going to say 3x squared plus 15x. I'm going to go ahead and write minus, and then I'm going to do FOIL over here, and I'm going to keep all of the FOILed stuff inside parentheses so that I don't mess up my positives and negatives. So 3x times 2x is 6x squared, and 3x times 5 is 15x, and negative 1 times 2x is negative 2x, which is going to give me 13x. And then finally, negative 1 times 5 gives me negative 5. And this is all over x squared plus 5x squared. And finally, I just combine any like terms. 3x squared minus 6x squared gives me negative 3x squared. I have 15x minus, notice that minus is going to distribute. 15x minus 13x is going to be 2x. And finally, minus negative 5 is going to give me plus 5. And then this is all still over x squared plus 5x squared. And that's how I'm going to leave that one. Okay. Now let's look at this one. You look at this one and you say, well, that doesn't look like a quotient rule problem, until you remember, of course, that we can rewrite tangent as sine over cosine. Now, you may already have the derivative of tangent memorized, and that's great if you do, but if not, we can come at it with the quotient rule. So we say low, that's cosine x. D high, derivative of sine is also cosine x. All right. Minus high is just sine x. Derivative of cosine is negative sine x. And finally, over low, so when we square cosine, we get cosine squared x. And we go ahead and simplify this. We get cosine squared on top, because cosine times cosine is cosine. Negative sine times negative sine is plus sine squared. And then we still have cosine squared x down here. Now, at this point, we have a couple of options. Notice that we could say one way of simplifying from here on out would be to say, well, cosine squared plus sine squared is 1. So that's one of our trig identities that we know. And so we have 1 over cosine squared x, which is, if you recall, the reciprocal of cosine is secant. So this is secant squared x. So one answer for us would be that the derivative of tangent is secant squared. We could also go ahead and split this up and say cosine squared divided by cosine squared is 1. And sine squared divided by cosine squared is tangent squared. Right? Sine over cosine is tangent, so sine squared over cosine squared is tangent squared. And an alternative form of the derivative would be 1 plus tangent squared. They are. This is one of our trig identities that we did see at some point. Those two things are equivalent. So just depending on how you go about it, it just depends on what form of that answer you get, but they mean the same thing. Okay, let's look at one more example really quickly here. And the reason I want to point this one out is because this one is able to be done by the quotient rule. However, notice that the denominator is just a constant, and if we take its derivative, we're going to get 0. And so we could think of this function as 1/7 times x cubed plus 4x. And if we do that, then remember that we can pull a constant out of the derivative. And we can just say, well, this would be 1/7 times the derivative of the stuff that's in the parentheses here, which is derivative of x cubed is 3x squared, derivative of 4x is just 4, and we get 1/7 times 3x squared plus 4, or we could distribute that 1/7 out and we get 3x squared over 7 plus 4 over 7. Probably easier than doing the quotient rule. So if you're just dividing by a constant, you do not have to do the quotient rule. You can. If you're careful about it, you'll still get the same answer, but probably not the easiest way to do it. But do remember that if you are dividing two functions, you must use the quotient rule to get their derivative.